All right, so today is about a new topic in Python called functions. We've been using functions already, right? Those are things that like other library makers have made for us, like the square root function, or like the turtle.forward function. That's just code that somebody else has written that you can call multiple times. That's all a function is. We're going to make our own today. Woohoo! That'll be nice. And then before we get there, I want to teach you about the other kind of loop in Python. It's called a for loop. It makes some things easier, and so that's why I'm going to show it to you. But technically, if you hate this and you only wanted to use while loops, you don't gain anything with a for loop. Sorry, let me fix all this stuff. For loops and while loops are equivalent to one another. Like, they give you the same amount of power. So technically, you do not have to use for loops if you'd like to fall asleep for this section. But I promise it's useful still. So this is equivalent in power to a while loop. Equivalent in power to that while loop that we already know how to do. Power to a while loop. Yes. Oh, shoot. I clicked it and it didn't work. Thank you. Sorry about that. My bad. Well, let's start all over. Boop. So, yeah, we're going to learn about functions, but before we get there, I'm going to talk to you about this thing called a for loop, which is equivalent in power to a while loop. There. That's what I drew. It is easier for some things. It's easier when you would like to go through something. So a for loop is a new kind of loop in Python that iterates through things that are iterable, which is a very vague thing to say. So a list, though, is something that is iterable. So like if you have a list, like L equals 4, 5, 6, you know how to use a while loop to like visit every element of this list and like add everything up or like print everything out. You could use the indices, right? You start a while loop with indices and like you go through all of them. There is a second option for things like lists that are iterable. Everything that I say for the rest of the day, you can just pretend it's a list because that's honestly what I want you to think about. But a for loop looks like this, and it makes it a bit simpler to like know what you're going through. It would go through a list in order. So like if I wanted to go through all these values, 4, 5, 6 in order, I could say this. For, and then I give a variable name, for x, let's say, in L, then you put a colon, and then you tab over and you give the body, and what's going to happen is body goes here, as many lines as you want again, goes here. What will happen is x gets a chance at being all of the elements of this list, which is nice. You don't have to like worry about indices. It's just if you want the values only and you want to go from left to right, just use a for loop. It's simpler. Say for x in L, it'll let x have a chance at being 4 the first time it runs the body, 5 the second time, 6 the last time, and then it'll just stop because it knows how many things are there. So that's an iterable thing that we can go through. Pretty nice. So let me show you that. I'll open up idle, make a new folder for today. Let's see, what lecture are we? We are lecture 22. And what do I want to call this? Let's call it for loops.py. And these windows are always so large when I make them the first time. But here's the idea. So I want to say something like this. I'll make a list, L equals 4, 5, 6, just like I had before. And then I want to iterate through it with this for loop thing. So for, I can give any variable name here, x, y, z, whatever, blah. For x in L, we say, colon. Now, every time we run the body of this loop, x gets a chance at being all the elements of L. So it's much easier to use a for loop to iterate through a list. X gets a chance to be every element of L in order. That's also important. You can go in order. If you want to go like in reverse order or something, you're kind of forced to use a while loop and do like indices and stuff. But if you just want to go in order, that's fine. And then we can print x. X gets a chance at being all these guys. So if I run this, we see 4, 5, 6 printed out. Does that make enough sense? It's like for x and L, let's x be all the elements of L in order, and you just work with x rather than having to like mess with indices and weird stuff like that. So there are some other helper functions in in Python that lets you generate list-like things. Like, let's say you want to like print the numbers from 1 to 100 in order. There's a nice range function in Python that will do that for you. So you can call it in a bunch of different ways. You got like a range. You can give it an ending value only, or you can give it two things. If you give it two things, the first thing's a starting value. So that's a built-in function. You don't have to import anything, but you can call range. If you want the numbers 1 to 10, you can call range and you say, I want it to start at 1. This will like generate a list for you. And the ending value, it always goes up to, but not including the ending value. So if you want 1 to 10, you need to say range 1 to 11. It's like the first number is inclusive. If you've seen this syntax before in math, like I'm generating the sequence from 1 inclusive to 11 exclusive. That's the idea, all right? And so if you want to start at some number, you give the starting value and then one more than the ending value, all right? It's always one less. It works like this. If you do not give a starting value, just call range by itself, the starting value is by default 0. So if you would like the range between 0 to 100, you can just call range with one argument. You can say range 101, right? Because it goes from 0 up to, but not including that thing that you give it for the ending value. That's the idea. That is range, and let me show you how that works just in the REPL. It's like you say range 1 to 11, and so that, unfortunately, it's its own little thing. It's its own little iterable thing. It won't print it out to you, but you can convert that to a list. Make a list out of range 1 to 11 if you would like to see it really, and that generates all those numbers for you. That's pretty nice. You don't have to run a loop to make that happen. And so that's both ways if you give both arguments. But if you want a range that starts at 0, you can just give the ending value. So range 101 makes all the numbers between 0 and 100, because it's always up to, but not including that final ending value. That's pretty nice. It's very, very quick to generate a bunch of numbers, and then you can use a for loop to go through them all. So that's the goal. Let me show that to you in code. So let me make just a blank line to separate stuff, and then let's do another loop. So let's go through and print out all the numbers between 1 and 10. So I can just say range 111 to generate all those numbers from 1 to 10, and then I can go through them with a for loop. Let's call it y in that range. Print y. And so that's a very easy way to print all the numbers from 1 to 10. Are there any questions about that? It's kind of nice. What else could we do? Let's say we wanted to like sum up all the numbers from 1 to 100. Okay. So let's say we wanted to do that. So what we need to do is we want to iterate, right? If we want to sum up all the numbers from 1 to 100, we want to iterate through all the numbers between 1 and 100, obviously. We need all of them. And then let's add them into like a sum variable, adding them into sum each time. Okay, so like I'll start a sum variable at 0, and then I'm going to iterate through every number from 1 to 100 so that they all have a chance at being added into sum. So I'll use a for loop, but I want to generate the range, right, between 1 and 100, so I'll say 1, 101, range 1, 101, starting at 1, ending at 100, 1 less than 101. So for, let's say z this time, call it z, in all the values in that range, one at a time, we'll hit the body, and I would like to add each of those into the sum variable. Sum equals itself what it was before, plus that new z, so add the 1 in the first time, the 2 in the second time, 3 in the third time. And just keep going, having fun, and that is that. And then by the end of this loop, once it's ran all those values, it stops the loop itself, once it's run out of things in its range. And we can print the sum, which is apparently 5,050. That's the sum of all the numbers from 1 to 100. So it's very quick. It's just like 3 lines to do that. Three real lines of code, which is pretty nice. About as good as you can get. Any questions about that? So useful. It's a for loop. Equivalent in power to a while loop. You could do all the same stuff by like generating, starting with variables and like counting from 1 to 10. We know how to do all that. But this is a bit faster for some things. So that's nice. All right. Now, if we're ready, let's talk about the meat of today. Let's talk about functions, okay? So, functions are the equivalent in Scratch of like, we have our own custom blocks, essentially, and we can use it as much as we want, okay? That's the goal. And they can take things, like we can make a block that takes something and does something with that particular value, and we can run it again with a new different value, because that's always, you can put something else in there. It's always going to get that. It's going to jump up to the definition and start running all that code. Remember all that? So functions are like that. They, in Scratch, they took a parameter. We say this is, n is called a parameter. It's just the fancy terms. It's its own little variable that's like set to whatever you run your block with that time. That's called a parameter. And you gave arguments to your block, essentially. So like this thing was an argument, and it was placed, like every time you ran this code, we jumped up to this block and set n to that value. So that's the goal. And then you know how to do this in Python already. You know how to call functions like range. That's a function. You can give it like an argument, 101. That's an argument. So we know the other end. We know the use end. We don't know the definition end yet. So that's where we're going. All right. So this is how you call a function. You say its name, give any of the arguments that it needs, and then maybe it gives back a value, and you'll save that for later, or do math with it or whatever. And so it's very similar to make a function in Python. If we want to make one, we have to figure out, like, pick a name for it. It's like not used already. And then we have to give names for all the parameters, all the things that we want to like work with. The user is going to give us every time they call us. And then we have to say what we do with those parameters every time we're called. So that's the body. We give a body to our function. What do we do with those parameters that we're given when somebody calls us? Okay, so let's slowly but surely talk about that. So here's what the syntax looks like to define a function. It starts with def, which is kind of nice. Very similar to this define block in Scratch. It starts with def, and then you give a space, and then you say the name of the function, what you want to make, whatever name you want. Call it func name, I guess, to be generic. And then you start giving parentheses, like pretend it's being called. And then you give variable names here, comma separated, for all the things that you want to have given to you when the function gets called. These are all your parameters. Like, I want this thing, I want you to give me this thing, call it P1. The second thing that the user gives me, call it P2. I can have as many of these as I need, have as many as you want. These are your parameters. Whee. And then you have a colon, and then you tab over, and you say what you want to have happen with these parameters when you get called, because that's what all the arguments are going to be placed into. Body goes here. So that's the goal, or the idea. You say how you want to use those parameters, like give back an answer, like do the thing you're setting out to do. And the beauty of functions is you can call your function a million times in a million different places. You just put all this code that you're going to repeat in one nice place, give it a name, and then you just keep calling it. That's the beauty of it all. That's why they're important to learn. So every time you call your function, it just jumps up to the definition. It starts running the body. So let's say we call our function, func name is its name, and we give it some real arguments, 42 and 43. So that's the terminology. The arguments are in the call, the parameters are in the definition. So there's two things, arguments. And the second you call your function, it jumps up here to the body, and it a split second before that, it starts setting the names of your parameters. It sets those to, why is that so small? It's supposed to be large and pretty. There. Like this 42 goes into P1. Like it gets set into P1 and then it runs the body. 43 gets set into P2. The arguments are set into the parameters at those same spots, and then it starts executing the body, and it comes back to the next line after it's finished. Like it'll come back down here. But it jumps up here and sets those values. The values of the parameters are set to the values of the arguments. So parameters are just variable names. So yeah, that's the idea. Parameters are the things at the definition. Arguments are the values or variables that you use when you call. Okay, I will mess up that terminology all the time, but I'm going to try to get it right for you guys. But that's the syntax at least. So let's make a function that we might want to use. Let's make a function. Our first example is let's do one that prints all the numbers from 1 to some value n that the user gives me. So I can make a function that could just as easily print from 1 to 5 as printing from 1 to 5,000. That's pretty nice. I can call it multiple times. So let's pretend we have it. Like, what do we want it to be called? Let's call it like print from 1, 2. Something like that. And then we want it to be called with a number here, and that number can vary, like print from 1 to 5, print from 1 to 5,000 if you call it with 5,000. And so we want that when we run it to like print out to the screen 1, 2, 3, 4, 5. Okay, that's the goal. So we need one parameter to hold this argument. Let's call it n, let's say. All right. And so we have our first line down then, if that's how we want to call our function. We know its name, we say def, we say print from 1 to 2, that's its name. And then you give as a variable name what you would like to hold every argument. So let's call that n every time we get run. Let's call our thing n. And then we have a colon, tab over, give our body. What do we want to do with n when we're called? All right. N is a variable for all intents and purposes. It's just set in a weird way when you call the function, right? But n is a variable that exists only inside that function. So like when you call it here, it jumps up and like it makes the n variable and it starts running the body with n set to 5 for this call to the function. That's how that works. So n it's a variable that lives for the life of the function only and only exists inside the function. That's the idea. Okay, so in the body we'll do some stuff with n. How do you print from 1 to whatever your n was? You just loop, right? For loop, while loop. And whenever we call this function, we say it once, Python just jumps to the definition, starts running the body with the parameter set to whatever we pass. So like the n is going to be set to the 5 and it's going to run our code. That's how it knows what we passed along. It's just like a variable. So let's code this up and watch it work. So I'll make a new file and we'll call it functions. Oops. Functions.py. And I'll make the window smaller. And so, all right, def print from 1, 2. And then we have our parameter name n. That's what things are going to be passed into. Colon, tab over, and so now n exists in the body. We were called, we get to use n here to print from 1 to n. So whatever n was, maybe like their user wanted us to print from 1 to 5, they would have called the function and n would be set to 5 here. It's a variable though. We don't know what we were called with because we can be called multiple times with multiple different values, but we know how to print from 1 to some arbitrary value. We can say for x in the range between 1 and, not n because that would go up to n minus 1, but we could say n plus 1 here. That would give me all the numbers between 1 and n inclusive. Print x each time. And so that's the definition, and that's all we want to have done every time we call this function, right? That's what it means to print from 1 to some number. And so I can call it print from 1 to 5. Run that. And what do you know? It'll jump up here, set n to 5, and start running. It prints from 1 to 5. How cool is that? Are there any questions about how that works? And again, the beauty of functions is you have this code once, it's generic, you can call it multiple times with multiple different values. That's the whole point. So I can call print from 1 to again, to print from 1 to 10 this time, and then n will jump to this body and n will be set to 10, and so it will run with that in mind. And so not only can it print from 1 to 5, it can also print from 1 to 10. It's generic. It's cool like that. So you can call this as many times as you want in separate places. That's the beauty of functions. Yeah. Any questions about how that's working? All right, so, oh yeah, what's up? Oh no, this is just like, this is just a style. So when programmers write things, you can't have variables with spaces in them, sadly. That doesn't work, so, or function names with spaces. So you gotta like separate the words somehow. This is one way to do it. It's called camel case, like the capitalization is like the humps on a camel's back or something. So you can separate words easily as you read it. Or some people like to use underscores. You could have called it this as well, but you couldn't have put spaces, and so we have to solve that problem somehow and make it readable. Yeah, good question. Any others? All right. So we have there's two kinds of functions. There's two different classes of functions. Functions that just go off and they do stuff for us, and functions that go and they compute an answer and give us that answer. So we've seen both kinds. Some functions, they just do stuff. Like our print from 1 to 5 function is meant to be called on a line by itself, and it just does the printing for us, yeah? Or like turtle.forward, it's meant to be called on a line by itself, it just does the moving of the turtle. Some other functions, like square root or like min and max, they give back a value, right? If you ask Python, it knows about minimum, so like min, what's the minimum between like 50 and 5? It's like, oh yeah, it's 5. And it gives back the 5. That's important, all right? So some functions just do stuff, but others give back things. And so it doesn't make sense to call min on a line by itself because you've thrown away the answer. Yeah? It's like if you run this line, what does min do? It gives you back 2, and you can think of it as like whatever it gives back is replaced here. And so it's really setting x to 2. That's what happens. So you can like set it to a variable, or you can do math on it. You can be like, let's do the result of min 23 plus max 23. Like that makes sense. You can use it in a bigger context. Like the minimum will get replaced. This will give back 2 because that's the minimum, and this will give back 3. And so it'll compute the number 5. That's the goal. And so you can do stuff like this. But if you want to see the answer, you have to like wrap it in a print, right? Because it just makes the answer for you. It doesn't actually show it to you. It computes it though. So you can imagine that things are going to get replaced when you call functions that give back values, right? That's a certain kind of function. So this will it gets replaced with 2 once Python can compute that answer for the minimum. Once that function gives back the value, and then it ends up computing 3 and printing 3. Okay, so that is in stark contrast to something like this. This line makes no sense at all because all print is the function that just does something for us. It's meant to be called by itself. Right? It doesn't give back a value like 42 or something. Like it makes no sense to assign the result of print into a variable because there is no result, right? Similarly, it makes no sense to add print calls, yeah? Because again, print is not giving anything back. It's just going off and doing something for us, all right? So functions that give things back, you think about them as replacing. Like their value, the thing that they give back replaces your large expression. You can use it in a larger context. But functions that go off and do something for you, they're meant to be called on lines by themselves. They just do the thing and come back to me, please. Okay? Functions, this function that we made just goes off and does something. Right? It doesn't give back an answer like that we could put into a variable. That makes no sense. Right? It just goes off and does something, just like print. If we would like to have a function that gives back something, we say return. Return at the end. Like return the value 42. That will give back the value 42 to who called you. Return is the answer here, and let me just try and spell that out to you. So like you know the math library, right? Math dot square root of 2, yeah? This is a function that gives back the square root of 2. So like if I run this program, I see no output. Does that make sense? Like I called math dot square root of 2. This is being replaced with 1.41 whatever, but it's as if I just said 1.41 whatever as its own line. It's not going to print anything. Do you see that? There's a difference there. It computes the answer, so I can use it in a bigger context, but if I ever want to see the answer again, I need to put it in a variable or something like that. Okay, so this makes no sense, this line. As well as doing something like this, print from 1 to. Do I want to do that now? No, we don't. This, print from 1 to 3, let's say. This also makes no sense. Calling print, wrapping print around this. Watch what happens. It says 1, 2, 3, none. Weird. So what is this doing? It's going off and it's computing this answer. It's like it's thinking that it gives back something. So it goes off and it calls the function, which prints from 1 to 3, and it gives back nothing at all. It's getting replaced with the function gives back a special value when it doesn't return something. It gives back a special value called none. So it's as if this call were replaced with the special value called none. Let's see if I can show that to you. So it's as if this happened after it did the printing, called the function. It's as if it said print none. And so that's why you see that. Okay? So this should look weird to you. This line should also look weird to you. Hopefully that makes sense. Okay? Any questions about that? So there's two kinds of functions. Functions that do stuff and functions that give you back an answer. All right, so let's make a function that gives back an answer. That's the other kind. We got to use return if we want that. I have to use the return keyword somewhere. So let's make a function called let's make it called sum. Do I want to do this here? We'll do that later. So let's make a function called sum. All right, and so it's a very simple function. It's going to do nothing exciting. It's going to add two numbers. So let's make a sum function that we could call like this, like sum the numbers 2 and 3 together. So it's just wrapping around plus, honestly. That's all it's doing. But this will be a good example of a function that gives a value back. So like you call sum 2, 3, it's giving back 5. And you could use that value that it gives back in a larger context. You can be like sum 2, 3 times 2. Wrap that in some parentheses or something. That will give back 10. Right? It will eventually compute 10 after all that works. Okay, so that's our sum function. It takes two numbers and gives back their sum. Right? And hopefully this shows you the difference between like printing something and returning something. All right. So let's show that. So I'm going to make a function called sum that takes two numbers and it gives back their sum. Just a plus operation, really. So def sum, because I want to use it like this, right? I want to be able to do something like this. Print, calling sum 2, 3, that's going to be replaced with 5, like times 2 or something. So def sum, how do I make this? Let's call the two parameters x and y. Those are the two things we're getting when we're summing. And so in Python, you say return blah when you'd like to give back blah. When you want to give back blah to whoever called you. Okay, so if I want to give, what do I want to give back in sum? It's just like whatever x plus y is, so I will say return x plus y. And it'll give back that answer after it computes it. So if I do that, and I run this, I see, oh gosh, do I want, let me add another space here because that looks a little weird. I see 10 because sum 2, 3 gives back 5. You just pretend it's replacing that with 5, its answer, and then it's multiplying 5 times 2, so it computes 10, and then it prints the 10. Okay, does that make enough sense? Any questions about that? So that's how you want to use this function, and so whenever you call it, you just, if it's giving something back, the original function call gets replaced with the value that it gives back, and you can do stuff with it, like multiply it by 2, right? So if you have a function that does not return something, you cannot use the result. It can't be like what we did up here. That prints none. Doesn't make sense. Okay? You're just forced to call the function on the line by itself if you do it that way. So yeah, let me show you. Just this is a very common error to make as you're starting out with functions. So that's why I'm hitting it very hard right now. Just like giving something back versus like printing something. Okay? So this is a good way of using sum. Here's a bad way of using it. Let's do sum 5, 10. Like that would compute 15, yeah? It would give back 15, but we see no output because we're not printing the result. We're not using the result. This is getting replaced with 15, so it's as if we had a line that just said 15. And it computes the number, it's just making the computer hot. We're not doing anything with the answer, though. Okay? That's the idea. We're not doing anything with this result. Sad face. So it just like vanishes into the ether. That's not how you call sum. You have to use it in a bigger place, like assign the result into a variable or something, because you're going to lose this result. It's not just going to get printed for you. Okay? So that's the goal. And so the right answer would be something like print the result of calling sum 5, 10. Because that'll get replaced with 15 and it will print 15. So everybody see the difference between this line and this line? That's the key thing I'm trying to get you accustomed to here. So, yeah, let me make the mistake that is very common amongst computer science students that are starting out. Let me make a bad version of the print function. So this is a good version of the print function that gives stuff back, and so that you can like use it in the larger context and make good answers. Here's a bad sum function. I'll call it sum underscore bad. Takes x and y again, and what does it do? it's not going to return x plus y. It's going to print x plus y, right? And so this function, by definition, gives nothing back. You cannot use it in a larger context, but it kind of looks right to an untrained eye, right? So this function is incorrect. Compare it with this one. What's it doing wrong? It's just printing. It's not giving back its answer. So you can't use it in any larger place, which is unfortunate. You would probably want that because this is math stuff. So, all right, here's something weird. You might think you could call it like this, like sum bad 2, 3, and like print the result of that. But again, this won't do the right thing. Okay, it'll mess up a little bit. It's going to print 5 and then none. This line prints 5 and none because when we call this, it goes in and prints 5, and then it gives back none. So like this is being replaced with none. It's as if we were saying, after we called the function, print the special value none. Okay? So you see how that's not really what you wanted. And now you're kind of unhappy. Here's something that will make you unhappy, or like print the result of sum bad. This is where the real error happens. Like multiply that result by 6. That might be something that you want to do, right? It makes sense to do that with a normal sum function that gives back an answer. But this function just prints. It gives nothing back. There's nothing to multiply by 6, as you would expect. So you're going to get an error, actually. It's going to print 9 and then give you an error, because all sum bad does, like print, is trying to get a result here. And so it's going to go off and it's going to call sum bad, which will print 4 plus 5. It'll print 9 to the screen, and then it'll give back nothing, right? So it's as if we said then, print none times 6. Do you see that? That's the issue. You can't multiply a nothing by 6. You need a real number. And so that's why you want this function that actually gives something back so you can use it in a larger place. This will be replaced with the thing it returns, the 5. Then we can multiply it by 2 and we get our 10 as we expect. Okay? So these two functions, I hope you can see at least a little bit of the difference between them. Are there any questions about that? It's a very common error. And so what I'd like to show you is a diagram form of how functions get called and returned. It'll help with this. So it's called the stack. When functions are being called, like we're adding stuff to like a stack of work to do, and we think about it with that kind of metaphor. And so let me draw like what's happening when we call this line. We're calling print of sum of 5, 10. Okay? So like we're sitting on, like here's all of our work we got to do. We got a stack of work. It's like a stack of papers. This is the technical term that we call it the function call stack. All right? So when we call that line, this line right here, we are like sitting in the outermost code. And so like that's the work we're really trying to do initially. We're trying to run all of our program. That's our outermost code. And then we come to this line. And we're like, all right, we need to call print. We need to print the result of all this. So like the outermost call here is print. And so we see print. And we want to print whatever that result is. So print is the next piece of work to do. And then we see, well, what does print print? It needs to print this result, sum 5, 10, and like we don't know the answer yet. Python doesn't know the answer yet. It has to go off and call that sum function. So like that's the topmost thing on our stack of work. Like that's the most important thing right now. I have to call sum, and then it can give its answer back to print, and then we're done with print, and we can be back in our outermost code. So it's like that's the hierarchy of work that needs to be done. That's what a stack diagram shows to you. And then you can also draw like the variables that are involved with every function. Like sum 5, 10, that's got x and y defined for it. So like you can draw it this way and be like sum, this particular call to sum has x equal to 5 and y set to 10 because those were your arguments being placed into those parameters. And so sum, what's going to happen now? Sum is going to go off. It's going to call itself. It's going to give back 15, right? So it computes 15, and it gives that back. It returns it to whoever called it. And it's print. It's print who was thinking about getting that answer back. It's print who wanted the answer so it could go and print the 15, right? So we get 15. Sum gives 15 back. It returns 15 back to print, and then it like takes itself off the stack, all right? And now the topmost work that we're doing is the print operation. And print has something to print now. It has the 15. It'll go off and do that. and then we see 15 on our screen, and now print is done, and then we run the next line of code. Run the next line. Does that make enough sense? That's a stack diagram, and that's this arrow is kind of like function returning. That's what it means. It's giving back a value, all right? And let me draw the same kind of diagram for this bad function. Let me do this one with this kind of printing, okay? And it will hopefully make it apparent like why you want to return something in this case, right? So we were trying to run our whole program. We were sitting in like our outermost code, and then we went and we called print of all this, print of some bad 23, right? And so the outermost call is print. We want to print something. That's the next piece of work we need to do. And then what is print? It's like whatever this gives back. So it has to go off and compute an answer, has to go off and call some bad with 2 and 3. So that's the next thing that gets called, some bad, and it's being called with 2 and 3, and those are its arguments. Those will be placed into the x and y parameters, same names, x and y. It's its own little x and y, just to that function, called 2 and 3, let's say. And so some bad, what does it do when it runs its body? It prints x plus y. It prints 5. So that prints 5 on the screen. And then it's like, I'm done. And it gives nothing back. Like print sees nothing. There's a special value called none that it gives back when you don't say anything explicitly with return. And so some bad returns none. And that's what print sees. And that's like, all right, yeah, I'll print that for you. Sure. That's what I computed just now. So some bad gives back nothing. And so that's why print sees nothing and it prints the special value none. It's like, all right, yeah, I did my job. Does that make sense? That's the difference between this call and this call. Hopefully the diagram helps at least a little bit. I'll draw more of those as time goes on. Any questions about that before I make some fancier functions? Alright, let's make a function to sum a bunch of numbers. So it's very similar to the printing, but let's sum instead. So we'll use a while loop just to remember. Let's make a function that sums all the numbers from 1 to some value. So here's how that's its name, and we want to call it like this, sum 1 to, like maybe we pass along 5, and that should compute, right? It should give back the result of adding up 1 plus 2 plus 3 plus 4 plus 5, which is 9, 10, 15. Yeah? So that's what we want. We can call it a million times with a bunch of different values too. So that's the setup, and we'll implement it. We'll be like def sum 1, 2, and like here's the value, call it n. And so we've been given a number n. We'd like to iterate between 1 and n, and keep on adding values into like a sum variable. So we calculate the sum, and we give it back. That's the goal. We return that sum. So what is the meat here? What do we got to do? We want to like have a sum variable, right? Sum starts at 0, and we want to keep modifying that. Like let's make like an I variable that starts at 1, and then we add 1 into sum. Remember that game? We played this a bunch of times now. And then we make I2. That's the next value I want to put into the sum variable. Add the 2 in. Now it's 3. Make it 3. Add the 3 in. Now it's 6. And then we add 4 in, and so on and so forth until we get what we want, right? That's the goal. So that's the game we want to play there. And so what is that in Python? We did this before, but now it's a generic. It's a variable that we want to go up to. So like I starts at 1, and while, let's use a while loop, while I is less than or equal to, not like 100 or something hard-coded, but n, whatever n is. N could be 5. N could be 500. So while I is less than or equal to n, I want to do something with that and like make I 1 more. And so that'll loop between I holding 1 all the way up to that n value that I care about. So we have a current value of I that I want to work with. I want to add that into sum. Sum equals sum plus I. That's the first line. And then we want to add like the 2 in the next round and the 3 in after that. So advance I as well. I equals I plus 1. Okay? So that will be our implementation. And then we can call it a bunch of places. Like we can call it here. We can call it down here. Somewhere else. Sum 1, 2. Let me draw that better. call it with like 5 again, but we can multiply it by some answer because it gives a value back, right? Because this will be replaced. We think of it as getting replaced with the value it returns, because we're going to return that sum value. This will get replaced with 15, and so it'll compute in Python like the number 45. We can shove that into a variable or like print it. That's the goal. All right, so let's code that up. Watch it work. And I'm going to give you another question based on this. I'll call this new file some functions plural.py, because there's going to be a second one that I'll have you try. But that's it pretty much. Like, here's how I want to use it. I want to be like print sum 1 to 5 and like multiply that by 3 or something. That would be nice. That's how I want to use this function. So let's make that function. Def sum 1, 2, call the thing that we're given n, and then I want to start sum at 0, do some fancy calculations, and then we want to eventually give back the final sum after I compute it up here with all my magic. And then return that, whatever's in sum now, because we filled it with the right stuff. Okay? So that's this part. It's like set I to 1, and then have I range between 1 and whatever n was. Could have been 5, could have been 50. While I is less than or equal to n, I would like to add into sum, whatever I is, like add in the 1, add in the 2, add in the 3, and then like advance I equals I plus 1. So like the first time I'm adding 1 into sum, but the second time I will be 2. 2 is still less than n, probably. Add the 2 in, add the 3 in, add the 4 in, and eventually it'll get so big that it stops. All right, so that's our loop, and that will compute 15, right? This will give back 15, and then multiply that by 3 because it's returning. We can do that, and then print whatever the result is. Okay, that is the goal. Any questions about that? Does that make enough sense? All right, so here's this. Now I have a question for you. Oops. Instead of this, now you try. You've learned a lot. So instead of making a sum 1 to n function that gives back 1 plus 2 all the way to n, make a sum all the odd numbers from 1 to n function. Okay, see how you might fix that? It's going to return the result of 1 plus 3 plus 5 all the way to n. So all the odd numbers up to and potentially including n if it's also odd. So here's kind of how you want to use the function. If you say your function will be called sum odd, let's say, sum odd 1, 2. If you call it with 7, that should compute 1 plus 3 plus 5 plus 7. All the odd numbers up to 7 starting at 1. Okay? And what is that result? It's 7, 10, 16. So that should give back 16. All right? So see if you can come up with that function. Take what I had, maybe change it a little bit. Got to give it a new name, of course. But see if you can make a function that sums up all the odd numbers, that when you call it with like 7, it gives back 16. And when you call it with 9, it gives back whatever 16 plus 9 is, I guess, what, 25. So try a bunch of options, because you can call it a bunch of times. That's the goal. Keep most of it. Change the name. You can keep the grammatical name. I'll show you. All right. That's my little timer. Did any questions come up as we were trying this? Do we see how to change it? It's really just one line, right? It's like, I would like to go, I don't want to try 2 next. I want to try 3 after 1, and then 5 after that, not 4. So which line needs to change? Do we see it? As I'm iterating, what made the 1 the 2? What made the 2 the 3? Yeah. That was making it 2, and then 3, and then 4. If we just change that to be 2, and that should fix it. Like it started at, if it was 1 now it's I plus 2 later. In the next round, that'll make it 3. 2 more will make it 5. See that? That's all you gotta do. So, more or less the same code. Just give it a new name. Oops. Let's put it down here actually. I'll call it sum odd. 1, 2. That's just advance by 2. That's all. Give back that sum. So you can again print all those values. Print sum odd 1, 2. What do we say here? 7. That would give back 16. And then you can, because it's returning something, you can use it in a larger context. Be like, multiply that answer by 2, please. Have fun. Oh, sorry, did I say it wrong? Sum odd. Oh, I gave 2 m's. Excuse me. There we go. And so it prints 16 times 2. That's 32. That's pretty nice. It'll also do the same thing if you do sum odd 1 to 8. If you like try this out, like it'll get too big. It'll still be like it'll go from 7 to 9, and then 9 will be bigger than 8 is the idea. And so it'll give back the same answer if you do it this way. Because what is this going to give back? Sum odd 1 to 8. It'll start adding, right? 1 plus 3 plus 5 plus 7. All the numbers that are less than or equal to that number that are odd. But then it tries 9. It's like, no, 9's a little too big. I'm going to stop now. So it'll actually give back the same answer if you give an even number. That's that. Which is kind of just a cool little quirk, little fact about it. Any questions about this answer and how it compares to the first one? Not too horrible, I hope. So yeah, functions are great. You'll see them for the rest of your computer science career. If you have to learn programming for whatever your major is, you need to learn functions because that's going to save your life. It lets you reuse code. So that you can just put it all the stuff you're going to do a bunch of times in one spot, and then just call it a million times. That's the job of functions. That's why people love them. So they're probably the best way to do that kind of code reuse. Okay? So that is functions in a nutshell. Everybody writes functions all day, every day, for the rest of their lives if they're computer scientists. So now you know how to make them. The last thing that I want to show you is just a concept that I kind of sidestepped as I was explaining this stuff, like this n variable. This n variable exists only for this call. It kind of goes away. You can't like print it later after the call is returned, like down here outside of the code, outside of the body of the function. Same with this n. It's like we call it local to the function body. It doesn't exist. It doesn't even make sense to talk about the parameter outside of that function because it's like we're not inside the function anymore. So that's called a local variable, right? The kinds of variables that we've been making so far, normally outside of functions, those are called global variables, which are visible to everybody, okay? So let me show you the difference, and that'll be it for the day. So the normal variables that I've shown you how to make, they're called global variables secretly. So I'll say locals versus globals. .py, you're ready for this knowledge? Let's see, something like this. All right, so if I just make a normal variable, as I've done, like x equals 42, that's a global variable. It lives outside of anything. It is visible to everybody. Any other function can look at that value that we just called x. They can use it. You can even change it. And so, like that exists for the rest of the program, that x. It's global, lives forever. So it's 42, and we can use it for the rest of the program. It's cool. All right. And that is not the same as variables that you make inside of functions are also parameters as well. Parameters are just special kinds of variables inside of functions. So if you make a variable inside of a function or like talk about a parameter, parameter is just a variable. It's called a local variable, and it belongs to the function and only that function. So only that function has access to it. The variable goes away once the function is done. Once it does its work and goes back to whoever called it. Okay? Parameters, they do count as local variables. That's what I was trying to say. So let's make a silly function called blah, and blah can it can inspect x. Any function can deal with global variables. That's fine. X times 2. That's cool. X exists in here because it exists everywhere. So that's fine. We can also make our own variables inside of this function. If we didn't have any parameters, this is an extra variable called y now. It belongs, or it lives in blah. It's local to blah, right? This is a local variable. That's its job. That's a local variable. And so I can still use it in here, print y times 2. But the second, and I can call this function all day long, of course, outside, blah. I just made that. It's the point of a function. But the second the function returns and we're back in the code down here, like y does not exist. Print y. Makes no sense to do that. Let me show that to you. All right, so this is going to work for the most part. It's going to be like, let's run it in our minds. So x equals 42. Cool. Make the variable x, print it. Then we've got, all right, we print our 42. Then we define blah, but we don't call it yet. Like this is just a definition. We don't even look at it until it's called. Once it's called, though, we jump to the body. So we're calling blah here. We jump up to the body, and then it goes and it prints x times 2. X exists inside of here. So it's like, cool, 84, there you go. You can always see a global variable everywhere. It's the point of being global. And then we make a local variable, local to the function. It's indented. Part of the function is called y, and then we print it times 2. It exists here still. We're still inside the function, so we see 6. But then once this function returns, we're done with this line, we go to this line, y no longer exists. It only was part of the function. It was only local to that function. There's no way to access it, okay? So that's the idea, okay? That's what's going on. So, that's that. Let me draw a stack diagram for how that's working. So like we were in the outermost code, right? And that's where we made this x variable. In the stack. Stack of work to be done. Outermost code. And we made an x variable there. That was our global variable, x42. Cool. And then every time you call blah, it makes y all over again. That's what it does. It makes y all over again because it's its own local copy of y for that call to the function. So you might change it differently depending on parameters and stuff like that. So every time you call the function, it's like we go to blah, let's do the work of blah. That's our high priority task right now. And then we make our y variable, set it to 3. And so that's why we see our stuff. And then once it returns, though, kind of me drawing a slash, and we're going back to the outermost code, we're going to the next line, you can kind of see why y is gone, I hope. That's the point of the diagram. So you can kind of see how when functions return, all the memory that belongs to them goes away. That's the meaning of all this. That's the difference. Are there any questions about that? It's a weird little quirk, but it kind of makes sense. Like if you make a variable up here and you can call blah in a bunch of weird different ways a million times, you don't really want to have guarantees about the variables that were used. Like that should just be part of that function. Don't deal with them outside. And that is what this language is forcing upon you. It keeps you sane, I guess. If you would like to, there's one thing you can't do to a global variable inside of a function without saying some extra stuff. If you would like to mess with the global variable x, say x equals x plus 1, this line would not work right now because it would try and be like, or it would make a local variable x, a new copy of it, because like we're defining a variable potentially inside of here. So this may either work or not work. Let's see. Yeah, it's like, I don't know what you're talking about. Cannot access a local variable x because you're trying to use global variables and local variables at the same time. So this line doesn't work when you already have a global variable called x and you're trying to change it inside of a function, because it's like, is this supposed to be a local variable also called x, or would you like to change the global one? So you have to tell it one way or the other. If you would like to set a global variable inside of a function, you have to just say, like, give this global syntax at the start, usually. You say, all right, I want to mess with the variable x that's global. I will say global x. So don't complain now, Python. This is just a line that means I want to modify the global variable x inside of this function. Please let me. I have a reason. So once you do that line, now let's run this program. Now we see different values. We print the 42, and then we define this, and then we call blah, which messes with x. It makes x 43. So like we're still in blah. It makes x 43 now. So we see the 43, and then let me draw that somewhere where you can see it. 43 there. So it makes x 43, and then it prints x times 2 there, and that's what, 86. So we see 86 as our output. Cool, that works. And then again we make our local variable y3, print y times 2 6. We see that output. So we see 6 output, and then this returns. We're done, and so y goes away. And so it makes no sense to talk about y in the outermost code because it's not a global variable. It was a local variable only. All right. So this gives you an error, and I hope you see why. All right. Any questions about that one? It's local variables versus global variables. Is that a question? No? All right. Yeah. So that is what I wanted to say about that. That's some new syntax in Python. It's very powerful. Functions lets you just write one thing and then just reuse it forever. It's glorious. So yeah, now you know. And I believe that is where I would like to stop. So yeah, no new assignment. You already got a programming assignment that's due week 14. So just keep working on that. And the rest of the time is for you.